Across the globe, droughts are becoming more frequent and more severe. And with agriculture currently accounting for 70% of global freshwater withdrawals, the way farmers use water is increasingly important. That's why water efficient drip irrigation is a key component of Farm from a Box, and we're proud to partner with Netafim to offer this technology to our farms. I'm here today with Mike Illia, Senior Product Manager from Netafim. Not only is Mike a leading expert in drip irrigation technology, but he is just a superhero in our world. He's been absolutely integral to helping build Farm from a Box into what it is today and has been with us from the very beginning. So, Mike, thank you so much for being here. I am really excited to talk with you and learn more about drip irrigation and the impact it can have on our food system. I'd love to start off by just learning a bit more about who you are and your role at Netafim.
Sure. So, a little bit about myself. I went to Cal Poly in San Luis Obispo. Kind of follow my dad's footsteps in ag engineering. So, I do carry an agricultural engineering degree. Focus of soil and water and hydraulics is really kind of my background. Before I joined Netafim, I was working for several of our distributors doing design, irrigation design, installation, selling. So I kind of know both sides of not just selling the product, but installing it, in different applications and that. And then, geez, for the last, it's almost hard to say, but for the last almost 26 years, I've been working for Netafim. When Netafim was a much smaller company, and I've been able to kind of navigate through the company as my needs, were met with more challenges. Like when I need more challenge, Netafim was basically there to kind of go along with me for my journey, right, as a professional. So I've done many different things for them, from sales to marketing to product management, back into sales to another stint in product management, which is what I'm doing today with filtration. And I also carry kind of like a team leader role for that department.
I really like that you've had your foot in all these different aspects of the company, because I just think that helps you develop such a well-rounded perspective of the company, of the farms you're working with, and of the product itself. And on that note, I would love to just dive right into the efficiencies of drip irrigation. So can you talk a little bit about some of the benefits of using drip irrigation technology?
When you're talking about, I guess, irrigation efficiency with drip irrigation, you really need to look at what are the other technologies that we're competing against, right? So you can take it from a U.S. perspective, a global perspective. It really doesn't matter, I guess. More globally, you're going to find a lot more flood irrigation, right? With more developed countries, you're going to see a lot more sprinkler irrigation, like center pivot type technology. In areas where there's more labor, you're going to find more hand move sprinkler technology, right? And all those technologies above flood irrigation do have their place and have had their place in kind of irrigation history, I guess, but the most efficient, method to deliver water and nutrients is drip irrigation. And it's probably anywhere from 20 to 25% more efficient than, say, a sprinkler system, because generally with drip, you don't have the losses of wind drift, for example. Like when you spray sprinklers in the air, right, you lose a lot of that to, I don't want to, not necessarily surface evaporation, but just evaporation, above the ground and with wind and how it travels and that kind of thing. With drip, you don't have that. And then, there is a kind of a surface evaporation component, which you will have with sprinklers, you will have with flood, and you will have with drip. Okay. But the difference is with drip, you're not necessarily irrigating the entire floor of the crop. Okay. So the percentage of evaporation is less, I would say. And then the other piece is, specifically with, say, a vegetable crop or corn, soybeans in the Midwest, or cotton or alfalfa, we're actually burying that product anywhere from, 6 inches to 12 inches deep. So that whole surface evaporation component basically goes away. Okay. So just So if that goes away, then the efficiency kind of goes up, inches up a little bit further, you know. So that's kind of big macro level, right? If you drill into kind of what makes NetFM drip irrigation different from everybody else, right? And let me just say, I try and come like to this point, like as if I don't have my NetFM hat on, okay? Just really from a purist standpoint. There's, you know, 4 or 5 big companies globally that do a really good job, that do a really good job. I mean, they have good products. Otherwise, they wouldn't be in business competing against us, et cetera. Okay. What really separates us from number 2, number 3, number 4 is like when you have a really harsh water condition with bad water quality, that's kind of where we separate from the rest of the pack, you know, where a lot of other products will get clogged up and plug. You know, ours just doesn't do that as quickly. Now, granted, you can put everybody's product on the worst water quality with, you know, poor practices, and you can plug anything. Okay, so it's not like we're immune to that. But our solutions, you know, they're just better, especially in harsh water conditions. And what does that really mean? Like if I drill down, okay, into kind of what it means, and not try to get too techie, but NetFM was the company that, you know, invented drip irrigation. I mean, so with that, you have, you know, all the original kind of tribal knowledge of the NetFM engineers, and over time. So I started in 1996 with the company. There was like about every 13 to 15 years, there's kind of, you know, within NetFM anyway, there's like this generational evolution or generational innovation change where we were here, and then, you know, the R&D, like we're talking right now, I guarantee you that our R&D team is working on something for the next layer of innovation, right? And that that all started back in, you know, the late 50s, early 60s. And, you know, there's a huge innovation in like 1977, 1978, when, you know, we were the first to come to market with a pressure compensating emitter. Okay. So what that means is if I have varying pressure in the line, or let's say I have a whole bunch of elevation slope on the property that I'm working or trying to grow crops on, you know, the delivery of the water will be consistent. So it's not variable on the pressure. Okay. Before that time, because nobody had it, everybody was, you know, every person and every design and every application was basically variable irrigation. So you had all this variance depending on elevation change, friction loss, all that stuff. And it just wasn't as efficient. So pressure compensation allowed, you know, systems to go from, you know, high 80% uniformities up into the mid 90s. And that, I mean, yeah. And, you know, and there is a relationship between uniformity and yield potential and all that. So you basically just allowed yourself, you know, more yield potential, like what we're trying to do with Farm in a Box. You know, more yield potential means more people eating more food and less starvation and more healthy people, right? So that part's, again, I could talk about this all day long, but that's in terms of uniformities and efficiencies, that's NetFM's thing, especially in harsh water conditions. Everybody's product's going to work on clean water out of from a municipal source, right? So I just want to make that clear. It's how does the products perform when you really put stress on them. And in this in like irrigation and stuff like that, stress means like harsh water condition, algae from a reservoir, organic material, organic and inorganic silts that are really fine, that we're pumping into the irrigation system. How does the drippers handle it? Stuff like that.
You mentioned that in many parts of the world, farmers are using sprinkler irrigation or flood irrigation, which have been great for taking a lot of the workload off of farmers, but they're just not as water efficient as drip. And so I would love to hear your perspective on what impact on a macro scale drip irrigation can have on our global food system.
Let me answer like this. So people need to remember that regardless of what method we choose, flood, sprinklers, drip, the crop still needs, X inches per week of water and nutrition to maximize yield. Okay. So it's everything above that we're trying to save. So for example, I need so many calories a day to maintain my energy level, my goal weight, right? All those, all the vitamins that I need, right? So that's kind of a baseline for crops as well. So if we don't provide at least that, then what you're going to find is a deficient outcome, right? Meaning you're not maximizing the outcome. So as long as globally people understand that crops need so many inches of water per week as the crop is growing through the life cycle, right? Then it's really about how can we be better with the excess that we normally would apply. Okay. So a good example of that is I'm just thinking alfalfa crops, because they're a really water hungry crop. Okay. And they're water hungry, whether it's drip, sprinkler, flood, right? But where we can really minimize the excess application is with drip irrigation. Is subsurface drip irrigation on alfalfa uses less water than every other application for the other reasons that I mentioned earlier about, no loss due to wind, minimal loss due to surface evaporation, stuff like this, right? So globally, the more applications that we can get to drip irrigation, it means that excess, let me put it this way. If we had 100 acres of water that our crops were going to use, let's say, I'm just going to say 100 acre feet of water, and our crop needed 1 foot of water. Okay. Literally that much, 1 foot of water over the course of the season, then we would need 100 acre feet of water in order to irrigate that 100 acres. But if I traditionally used that 100 acre feet with sprinkler and I went to drip, because drip is 25 or 30% more efficient, then that means I can take that same amount of water and I can put it on 130 acres of crop. Okay. So this is really where we need to get countries and influence and regulation. I mean, that's really the impact is if we have enough water to feed 1 billion people, right? But the billion people are irrigating with flood and sprinkler. If we can get them to drip, then all of a sudden now we can, not only can we feed 1.3 billion people because of the efficiency gain, but there's also a yield gain when you go to a more efficient system. So maybe we can increase the yield by 15, 25%, 30%, right? Now, all of a sudden I'm looking at 1.6 billion people I can feed instead of 1 billion people. So this is the opportunity and the delta that we're trying to get people and governments to understand. But it's like with any kind of technology where you're going in to try and influence, right? It's people need to see it work, right? They need to see the value, the testimonial, and then they need to really look in the mirror and say, are we gonna put a stake in the ground and we're gonna support this effort? Right. Because it takes money to do that, right? It takes investment to do that, and that's where it's at.
So let's zoom in a bit and talk about this on a micro scale. You mentioned that farmers can see a 30% increase in yields using the same amount of water as they would with sprinkler or flood irrigation. But what does that really mean, both for a small-scale community-level farm or a large-scale commercial enterprise?
A small farm generally is going to use the same water source for irrigating crops and drinking, right? Okay, so if you're already water starving, water short, and you can use that water 30% more efficiently or 50% more efficiently and grow high quality produce, right? I can make an argument that that water that I saved allows me to have more drinking water for my little small village or my family, not feel so stressed about, are we going to have enough water to make it to the end of the crop season? Are we going to have enough water to drink in the end of August, September, when it's still 105 degrees out with, you know what I mean? Mm-hmm. So there's also some peace of mind about growing beautiful crops and using less water. It is also just being a good steward of the earth that we're working, right? And also, that extra water left over, now I can decide, hey, wait a minute, maybe I can use that extra water to grow more fruit, more vegetables, maybe for my neighbors or for my, and if my neighbors see, well, how did you come up with so much produce with the same amount of water that we have? And, oh, by the way, drip irrigation, and here's why, right? And it's like, it can be infectious in a good way. With big farmers, so this is actually hits home pretty well for California with like reduced water allocation.
Right.
Farmers in these circumstances have super tough decisions to make. It's like, okay, if I'm going to use just kind of grab stuff out of the air, right? But if I farm 1,000 acres of ground and I'm relied on non-well water allocation, meaning I'm not pumping it out of the aquifer, right? I'm getting it from a canal or a ditch or something where I'm paying for the water. If that allocation is 50% less than a year ago, or in some cases 80% less, now I got to figure out, okay, I can't put 20% of the water on 100% of my crops because it'll be a disaster, right? So now I got to choose which acres am I going to take that water and go grow what I need to grow. So what drip allows you to do, I guess, is it allows you to farm, even in a stressed condition, more acres than you would have been able to if you were using a different technology, like sprinklers or flood. That's really what it gets down to. And when you really kind of drill down from there, if I can grow 200 acres with drip with reduced allocation versus 160 acres or 140 acres with sprinkler, then I'm, that's gonna give me an extra, X number of acres that I can actually go and farm, get solid yield, get solid quality, get solid revenue. All this stuff stair steps down to available money for the farm per acre at the end of the year, right?
Right.
So
yeah, and that makes a massive difference for farms, not just the ability to stabilize your production through something like a drought, but to actually be able to increase your revenue. And, that's actually the perfect segue into my next question. You've kind of alluded to this a little bit already, but I would love to learn more about how drip irrigation comes into play with things like soil health and increased crop nutrient density. What impact does drip irrigation have on that?
Yeah, so great question. So you've heard, maybe you haven't heard, so I'm going to ask you. You've heard the term, oh, we're going to spoon feed this crop, right? Okay, so that whole term came to pass when drip came to the market, because we're literally dripping, we're dripping the ground, and we're allowing, the ground to take it up in a manner that is not, it's not like flood irrigation. So there's something so this is part of the excitement between soil and water, and the relationship between soil, water, and the plant and what it uses. And this, every crop needs so many, like I mentioned, like through the growing cycle, needs so many inches per day. And it's not like 3 inches a day, it's like 0.3 inches a day, 0.25 inches a day, depending on where you are in the country, and what crop you're growing and what stage that crop is. Okay. But it does need roughly between, let's say, 0.2 and 0.4 inches per day at peak usage, to grow to grow a non-stressed crop environment, let's just say crop quality. So drip irrigation allows you to do that with the application rates that you're putting it out. Is you're putting out super slow, and trying to match, actually what you're trying to do with drip is match the crop usage with the application rate of the drip emitter and the spacing and the pressure and all of that. You're trying to match that, that 24-hour requirement that the plant has. Generally, we want to be able to hit that within a day or every other day to keep up. Okay, so that we can, so the plant's growing and with the water we're applicating is like this right through. We don't want this big spike of irrigation, like flood irrigation is the worst for that, because you're putting all this water on top of the soil, right? And then it basically, as it works through the root zone and then out of the root zone, and it leaches out. Mm-hmm. Well, that's what we would call like non-beneficial use for the crop. Now, there's some beneficial uses for leaching to help like recharge the aquifers and push the salts down, through the root zone and out of the root zone. So I want to make sure that kind of gets mentioned, right? But with non-drip applications, what you'll find a lot of application rates of the technology is greater, and this is really key, is greater than the infiltration rate of the soil. Mm-hmm. So each soil is kind of site specific, right? There's some commonalities between soil types or soil classification, but truly, I could go on a piece of property, I can go on a 10-acre piece of property and I could find 4 soil types, mm-hmm. 4 different soil types, right? There's not like one uniform soil type through that whole property. In many cases there are, okay, but this is why we say, hey, did you do soil tests? What, and Soil Conservation Service has just great mapping over the years about getting you general soil types and percent sand, percent clay, percent silts to give you this information. So once we have that, then we can gauge, how far can I push the drip system in terms of application rate to not like overtax the soil. So if the application rate is higher than the infiltration rate, then I get a bunch of runoff. Mm-hmm. If I get runoff, right, then I'm also potentially putting those nutrients, let's say I'm injecting fertilizers, for nutrition, mm-hmm. Then I'm also potentially wasting that resource. And we don't want fertilizers in our creeks and our rivers and stuff like this, right?
That's such a great point. Protecting local waterways and soil microorganisms and pollinators is something that we're really passionate about at Farm from a Box. And, it's a big reason that we do what we do. And I know the same can be said for Netafim. And I think that's why this is such a valuable partnership. On that note, I would love to hear your perspective on Netafim and Farm from a Box working together and the impact that we are already having on our food system and, the even bigger impact that we could make in the future.
Scott wanted to meet, well, he met with some of our people globally, and then he wanted to meet like our local Fresno base. That's where our corporate office is at. And in the discussions with him, what we tried to do is when I think we're pretty successful at it, is he had a like a plot plan or a, you know, a 1 acre plot target, a 2 acre plot target, you know, and inside that acre, it's like, okay, let's think about the nutritional values of different food sources for human beings, right? We can't just grow all lettuce and broccoli. You know what I mean? I mean, we need some fruit trees, and we need maybe some almonds for a protein source, and you know, a bunch of different crop types to basically to meet the nutritional needs of people. And so it was really just great to collaborate through that. And so through that collaboration, we came up with a whole like a really unique specification of different products, different emitter flow rates, different spacings to kind of match the plant spacings that they were talking about and row spacings. And I think the real nice thing that I can say is we didn't look at like the collaboration from a engineering point of view. We looked at it from like a human point of view. What do we need? Like if I'm, you know, you almost have to picture yourself and your family, like your whole big like extended family in a village with you know, struggling for food. It's like, what would we want? How much do we need to grow, and what types of crops do we need to grow? And then kind of work from there back into like the whole product specification and how many feet of this product and how many feet of this product and what does the layout look like. And so I think from more of a like humanitarian point of view, that's kind of what we did. And I think it turned out pretty cool, you know, and it works.
And it works. You know, I love that you're touching on the crop diversification, because I think that's one of the biggest benefits of Farm from a Box is that we are entirely crop agnostic. And if someone's interested in producing corn or alfalfa, we can definitely do that. Or as you said, we can grow lettuce and broccoli if that's what you're interested in, or we can grow fruit trees, you know, and that's so important, not just for human health, but for soil health, pollinator health, you know, being able to have a diverse food system and a diversity of crops that we're growing is absolutely critical.
Yeah. And I just, you know, the other part is I think whoever gets to view this, it's from my standpoint, it's really important to know that the people like behind Farm in a Box, you know, they're trying to change the world with one container at a time, you know, one village at a time, one improvement at a time. I know it's working, and we just need to get this word out more from a, you know, opportunity standpoint, you know, with different governments and regulation, because not only are we saving water and being more sustainable on the footprint that we're irrigating, right? But the quality of food that we're growing with these systems compared to what the localized people are used to getting is so much different. It's like, what did the farms look like, or the villages and the farms look like prior to Farm in a Box? And then what did they look like after we put Farm in a Box in the location? Mm-hmm. And just because it is so vibrantly different, right, with the crops and how they're growing, and you know, it's really it changes people's lives, and it's just a beautiful thing. So,
well, Mike, thank you so much for your time today. It has been an absolute joy talking with you and learning from you. I know all of us at Farm from a Box are so grateful for your partnership and your support and your guidance, and we're just so excited to see how this partnership continues to grow and the impact that we have on our food system. So thank you so much, Mike.